with our toolpath, this machine group has already been selected, so what in your case, what you guys gonna do, you're gonna just go ahead, make sure you bring your toolpath and you just pin it down so you can see this all the time. So here in your case, you're gonna select machine type, go to machine, and go to mill, and pick mill default, and the same group is you're gonna see here. So I can just go ahead and click on group 2 and I can delete that one. There is gonna be group 1 right there. So that is gonna be in the machine, mill, and select default will give you your machine group number 1, and that's where we're gonna start doing our setup. On 2023, the major change we saw that is in your stock setup. The rest, there's a little changes on the 5-axis. We don't need to worry about that. Other than that, everything looks pretty same like 2022. So the stock setup is a little different. Okay, so going to stock setup, and here this page is totally different than 2022. Let's try it. So here comes your machine first. It shows you that machine model right here. We don't care about it. I mean, if you have a different model, you can always have your model set up in that folder. You can look for that model. But it's the same as 2022. So, but here, when you click on that, they just show it right here. This is only for your simulation purposes. So don't worry about that. And then here comes here your master model. Your master model is, you can select your master model. This is something new, and you can select with add from a level, and the level is going to be the surface. So I can select that and say I'm going to select from surface level. And this comes for your stock setup. And you don't have to select this, guys. Everything works in the stock setup right here. So under stock setup, there comes your bonding box. Add from a bonding box. So you're going to select the bonding box. In 2022 and previous version, we had an option that you can just select like 3 different ways you can select it. But here, this is a little different. That's okay. So here, I'm going to select my origin right here. You have an option, upper left corner, upper lower, upper right, upper left, and then in the middle. Select that. My origin is going to be right here, looking at this part on the center, at the top. And then I'm going to select my entities. Just click on select, and you're going to select all these. Here we go. And say end selection. And this will give you the size of your stock. Exactly the size of your part is going to be, which is going to be your length, width, and the thickness. So we got 3¼ by 3¼ by 1 inch. And here, when you are in bonding box, you can always go ahead, if you have extra material, you can always go ahead and extend that your stock right here. It's going to extend equally on both sides. Same thing on your Y also. You can do that. And same thing with your Z also. You can reduce that, or you can extend that, your size of the stock. Look at that. You can do that. But here I will keep my stock size same as your base, which is 3¼ by 3/4. So I can go ahead and select one more time, because I don't need that one. I just need this guy right here, which is going to 3.25 by 3.25. All I'm going to go ahead and increase this to 1.5, because we need extra material on the bottom where we can hold on to the vise. And 1 inch is gonna be my part thickness. So our stock is gonna be 1.5 inch. So we have like 1/4 inch, maybe 3/8, we're gonna hold on to the vise. So we have extra material left over. So we're gonna put this 1.5. All right. And we can just say okay. And that shows you also the size of your stock. So we have 3 1/4 by 3 1/4, then we have 1.5 inch. And plane, if you look at here, my Z0 is on the top. I'm gonna move my Z up on the stock about 50,000. So otherwise, if you already have a Z0 on the top of the part, your tool is not gonna do it. It's not gonna touch. It's gonna barely kiss the top of the part. And it's not gonna machine it. So here in the stock plane transformation, I can move my Z up about 50,000. So here my Z, if you look at from the front here, I have moved my Z, it was 0 over here earlier. So in that case, if my top of the part, Z0 is on the top, the tool is gonna just barely touch it, it's not gonna machine it. So I have to have extra material here. So I'll put 100,000 or we can put 50,000. So 50,000 is a good number. There we go. So I have 50,000 here extra that my tool is gonna cut on Z0, so we have 50,000 here to machine it. So that is gonna be under your stock plane transformation. And then you can move your origin. You have another option right here. If you want to move your origin, go to the top plane. You can say I'm gonna move my origin not in the center, I'm gonna move an origin 1 inch on X. It's gonna move 1 inch on X. I want to move my origin 1 inch on Y, and X is gonna go 1 inch X and Y also, so you can move that also, just your origin. So, but here, that does not make sense to move your origin. My origin has to be the center, or I'm moving my Z up 50,000. And what else we have? Okay. Going back to your stock model, here, that's my Z up, and you can create lines and arc. I will do that. What does that mean? That wherever the boundaries of your stock is gonna be on X, Y, and Z, it's gonna create, if it's a straight linear lines, it's gonna create a line. If there's any arc, it's gonna create an arc. That's what that means. And also, you can add a center point on the faces. Faces means it's gonna create a center point of the face on this face, and on this face, and on the top face, on the side face. It can create a center point where you can easily select an origin of the part if you want to do that. So let me show you that, and if you don't need, we can just go ahead and delete that, but you have that option, face center points. If I'm gonna hit OK here, so look at this, that's where the center point you have on all the faces. On the side face, let's say you want to do an operation on this side, so you can just rotate your part and you can make your origin by selecting that point. Or on this side, or on this side, or on the top. So that's what that is. But if you don't need that, you can just go back under bounding box and you can uncheck that I don't need that center point. So it's unchecked already. So every time we shift moves my origin, make sure the origin is on the top. So we can do that and make sure I'm going to create lines and arcs for sure. And hit OK. And then under transformations, I have 50,000. That's good. So hit OK. points, my origin is right here on the top. So let's say your part, this usually happens when you are merging or transferring from SolidWorks your stock, and you start, let's say your stock is over here somewhere. That's where your stock is, and you want to, I mean, your model. This usually happens. It will never come to the origin when you merge that file. You're gonna bring that file open, or you merge a file from SolidWorks or any other file, doesn't matter. So it will just float around somewhere right here. In this case, you can just have that point, which is good. You can just always go, and you can say transform, move to origin. So I'll say select the point you translate from. I want to translate from that point right there, and that will go and move to the origin. This is the first thing we always do, especially when you're creating, or when you're merging any model from other software than Mastercam. Usually you do SolidWorks. So wherever your part floats, you have that point. You can set that point, and you can move that point to the origin. That's going to be your part 0 right there. Okay, looking at the front view, we are good. And now I don't need those points, guys. I can just go ahead and select all my points right here. Select all the points, and I can hit delete. I can delete this. We don't need that. Also, I just need these guys here for my containment boundary. I don't need this. So if you guys remember that when we went to stock setup, and where was that? When we went to stock setup and we selected the stock model, it always changes when you go that. So remember we selected here lines and arcs. So the boundary was 3.25, 3.25 inch and a half. So it enclosed that boundary, and it created lines and arcs. So those lines and arcs are right, these are the lines and arcs it created. That's the size of the solid, our stock. So that's why it does that. So we don't need this. I'm gonna just go ahead and get rid of these. I just need the top part for my containment boundary. We don't need that. And I can just go ahead and get rid of that. And there's one more right there. We don't need that. Oh, I got duplicate because I did twice. Perfect. In that case, I can just go home and I'll say delete duplicates, delete the whole line, and perfect. So I don't need this. Delete it. All I need the top part right here. Or you can have the bottom part right here. So containment boundary doesn't matter. It's on the top. It's on the bottom, it doesn't matter. So that's all we need, right click, clear colors. Okay. So, going back to stock setup. Rectangular, we got that, we have that, that's good, face, slide that out, that's perfect. And under the first one here, we should have a program number. If you want that, this is something different, guys, than 2022. So here's the default your program number. You can put 1, 2, 3, 4, any your program number. Sequence number, start with N100, goes with increment of 10, or you can go increment of 5. So it's going to start with N100, 105, 110, 115, and so on and so forth. So So that is that. Where we have, these are going to be your tools. So these tools are, right now you see this, they are all empty because we haven't selected any tools yet. Once you're going to select the tools in our operation, you're going to see all the tools right here. So speeds and feed, same thing like your other version, guys. You're going to select from tool or from material. I don't use that. This is, we can try just from default, but we can always change the speeds and feed in the program. So it depends from machine to machine what's going to be speeds and feed. Assign tool number sequentially, yeah, that's very important. So you have tool number 1, 2, 3, 4, 5. Warning of duplicate tool numbers, no, you don't need to worry about that. And what else we have over here? So that's that. And these are your fixtures. If you have any fixtures, you can bring the fixtures in, and that will show your fixtures, so we don't need to worry about that. Hit okay. Alright, so let's go with our first toolpath. Okay, so once we select the machine type, there comes your toolpath, and you're going to see you have 2D, this is your 3D, this is your multi-axis. So we'll be dealing 3D toolpath right here. There's some toolpaths are here, and what we are looking for, what we know the toolpath you're going to use, if they're not here, guys, if you right click here in the white area, not right click in the black area, in the white area, you have more toolpath. You go to mill toolpath and move across. There is your surface rough toolpath. There's your surface finish toolpath. Then we have 3D high speed toolpaths also. And there comes your multi-axis toolpath, which is going to be these guys right here. So all your 3D toolpaths, which you don't see here, is going to be, like I said, right click, mill toolpath, go to surface rough, they are right here rough, and go to surface finish, they are finished right here. So we can select from here also. So the toolpath I'm going to select is going to be radial. Radial is a really good tool, and we're going to try a few different toolpaths. So radial, we're going to start with that toolpath. If it's like a circular toolpath, so it's going to start cutting from and come from outside into the center of the part. That's called your radial, and we have to tell the origin where it's going to rotate about the tool is. So we can try with your radial, and like I said, that there's going to be a whole lot of different toolpaths we will be using it. And that radial toolpath, if you look under here, I don't see it. Oh, it's right there. There's a radial toolpath. So we can use radial toolpath on this one. All right. So let's. We talked about machines, select a machine. We talked about group, and we talked about stock setup. There comes my toolpath group. So let's go to toolpath and go with the. Okay, there is a radial finish. I want to go radial rough, and I don't see it over here. That's what I was talking about. So if I'll go right click here, go to mill toolpath and go surface rough, there is my radial rough. Click on that. It says select a boss or cavity. This is my boss. Cavity, if you're cutting pocket inside, that's going to be your cavity. So now when you're going to cut the cavity here, okay, again, undefined will work fine also. You don't need to worry about that. If you want to say undefined, you click that, that's fine too, it will still work. So I'll just say I'll select a boss and hit OK. And it says select solid phase surface or match. These are all my surfaces. I'm going to right click, drag it to make a window and click that, select all the surfaces. Hit end of selection. Okay. Here, it shows you how many drive surfaces. Drive surfaces is the surface where your tool is gonna machine the part, where it's gonna be intact on the surface, those are called your drive surface. Your check surfaces are gonna be a surface where you do not want your tool to touch it or to cut. So sometimes we have that situation there where I want to cut certain surfaces and I want to stay away from a certain surfaces, so my tool will not touch the neighbor surface. I want to stay away from that. Those will be your check surface. We'll talk that in different projects, what are check surfaces. And there comes your containment boundary. We can use containment boundary, we don't have to. Let's try our containment boundary. What containment boundary is, you're telling the tool that, hey, I want to, if I'm gonna take this as a containment boundary, I'm telling my tool just stay inside that containment boundary or a containment boundary, or your tool can start outside from the containment boundary. So, let's see without not using it. I'm not gonna use containment boundary because I'm pretty sure that we have selected the surface and that should be okay. My tool is gonna stay on those surfaces. So let's see how that works. If it doesn't work, we can come back and we can select the containment boundary. Okay, and hit okay. I wanna show you one more thing. Select radial point. The radial point is gonna be right in the center. So let's go ahead. Radial point is right in the calculation. Yes, so select no. And I'm gonna go ahead and delete that toolpath one more time. Say yes to delete it. We're gonna start one more time. Right click, middle toolpath, surface rough, radial. Select the boss. Hit okay. And selection. So here it shows you that drive surface, fourth drive surface has been selected. So you want to see it, sometimes you want to keep some check surface. So you want to see the drive surface, hit show, it will show you what has been selected. It will show you. But the check surfaces will not show as a chooser like the way you see it. So that's really good, this thing to see that how many surfaces are selected, and you want to see it, just say show, it will show you those are selected surfaces. There are 4 drive surfaces or solid has been selected, so hit okay. And then it's the same thing, your check and containment boundary I'm not gonna use. Then you're gonna select the radial point. Your radial point is gonna be always the center of the part, where it's gonna come and stop. So here comes my radial point. That's my radial point is right in the center. And hit end of the selection. And hit okay. Okay. Ball ender. I'm not using a ball ender. We are doing a rough surface. So on 3D surfaces, guys, if you look at these parts are a 3D surfaces, and you cannot machine these parts with the regular flat ender. You cannot. It has to be machined with a, we call it ball end mill. So
for Office 3D, you gotta use a ball handle?
to finish. So there are 3 different steps you can follow. Your first step is gonna be rough. Second is gonna be semi-finish. And third is gonna be your finish. Rough, semi-finish, and your finish. Your finish pass is always going to be your ball end mill. For semi-finish or for rough, You can use bullnose. Bullnose end mill. With rough, it depends on your experience. If I want to do this job, I can use a regular flat end mill. So I can rough it out, leaving about 100,000, and then come with the semi-finish with the bullnose, and then I can leave 30,000, and then I can finish the 30,000 with the ball end mill. So I can use a flat end mill if I have to, and I know what I'm doing. I can use a flat end mill, that's not a problem. But we're gonna avoid using flat end mill. We're gonna use for roughing, we're gonna use bullnose end mill, and we're gonna use for finish, it's gonna be ball end mill. So your bullnose end mill is something like this. It has a corner radius, and then it has a flat. It has a corner radius and a flat. So this corner radius could be 1/32, this corner radius could be 1/16, this corner radius could be 1/8. It all depends, comes in different sizes with the corner radiuses. So that is your bull nose end mill. You're gonna use this for rust. And then your ball end mill means like a ball, it's spherical. Here is your ball end mill. And it is, could be any size, 1/2 inch, that means the diameter or radius is 1/2 inch, or 250, or 3/8, or 1/8, doesn't matter. So the way this works, guys, is ball and mill, every time it's gonna intact with your part, right? Each corner, it doesn't matter if, let's say, if the same part I'm talking about, this part right here, this part, your ball end mill is gonna cut this part, the tool is gonna intact with the part all the time, and it will cut anyway if it's gonna intact with part like this, right here, look at that. It will cut it with this part. When it's gonna move up, maybe it's gonna attach with this part, and this top part is gonna be right here. So every time your tool is touching, it's intact with the part, it's machining. So in this case, your step over, that's why those parts take so long time to finish it. Your step over is gonna be anywhere from 0.2000 up to 20,000, it depends on the finish of your part, could be 25,000. But the finish you see here, this step over is anywhere from 8,000 to 10,000 step over. So just imagine each time this tool is moving up on each surface, it's cutting 8,000 or 10,000 step over. So that's why it takes a long time to just finish this part, because your step over is really small step over. Not like your step over for bullnose end mill. I can step over, I can go 60% of that. If my 1/2 inch, I can go 300,000 on step over. And the same thing, rough end mill, the flat end mill, the step over, I can go 60% or 70% of step over. But with a ball end mill to finish this, the step over is gonna be anywhere from 5,000 to 10,000. All the parts we're gonna do here, we're gonna step over, we're gonna use 8,000 to maybe 10,000. And you can see the finish, when some finished part has a 12 or 15,000 step over, and that finish is gonna be like a rough finish. So we'll stick with bullnose for our rough, and ball end mill for our finish. So here, coming to selecting your tool, I don't know how this tool came here, ball end mill, I couldn't even select it. So I'll go to select library from the tool. I just click on that tool, I hit delete on my keyboard, I want to delete that. So select library tool, and you go to filter. This page is also different than 2022. This is the first time I'm using it, so let's see. Yeah, it's a little different. So here comes your bullnose end mill. Look at that. End mill, bull, and this is your ball end mill means sphere end mill. Same thing, ball or sphere. And this is your regular flat end mill. So I'm going to select bull end mill. Sometimes it's select all like this, guys, when you're going to say, so make sure you hit none, and then select the one you want to select. I'll select bull, and you ignore the size, it will show you the whole list of tools, and if you know that, what tool you're gonna use, then it is gonna just show that, so I'll say equal to half an inch, 0.5. But, or you don't, you wanna say ignore it, I can just go and ignore it and hit OK. It will show you my list of all the bolt holes. So here, look at these corner radiuses. These are your corner radius, this is your diameter. So here, if I'm looking for half an inch, I have a corner radius 0.062000, I have a corner radius of 0.3125, and this is what we have on machine. So I'm gonna use that, corner radius 31,000, half an inch bolt angle. And hit OK. That is your tool number one. For the corner radius 31,000. Okay. And this is where I was talking about speeds and feed. So we'll be using this polymer material stock, and our feed rate here, I can easily go 75 inches per minute, my feed rate. Plunge rate I can go 50 or doesn't matter. Retract I can go 100 on retract. Spindle speed, I can go 6,500 on spindle speed on that easy. So that's my surface feet per minute is 850. Or even you just go to 900 surface feet per minute, and that will take care of your speeds and feed. Usually, if we are cutting aluminum, our surface feet per minute will go 650 to 600 cutting speed. So that speed is 4,500, feed rate is 52, but even if I'm cutting aluminum, that spindle speed is slow for me. I can easily pump it up to 5,500 spindle speed. So I'm just talking about the material what we are cutting. So here, let's go use cutting speed 900. That's going to be good for this part. Feed rate is 66 inches per minute. Plunge rate is going to be 50. And here under the comments, you can just put here carbide, half an inch, 0.5. Diameter and bullnose. Bullnose and all right. Okay, so let's move on to your surface parameters. The surface parameters is pretty default, is pretty standard. We can stick with most of the default. Here your clearance, you want to go, tool is gonna come at 2 inches, and then it's gonna retract to 4 inches. It's gonna come rapid to 2 inches, then rapid from 2 inches to 250, and then it's gonna start feeding 100,000. Incremental, absolute doesn't matter in this case because the top of the part is your Z0 right here. You can go into stay in absolute, that's fine. Now here I want to rough it out, and I want to leave about 30,000 for finish. Start to leave on the drive surface. So it's gonna rough out everything, but it's gonna leave 30,000 on the drive surfaces. Feed plane 100,000. Tool containment compensation. The center means the center of the tool stay right here on the center. Inside means your tool is gonna stay inside the boundary. outside means your tool is gonna stay outside the boundary, that's what that means there. So here, if it's my part, like this is my part, center means your tool is gonna cut to the center, it's gonna stay right center on the part. Inside means it's gonna stay inside, outside means it's gonna stay outside your containment boundary, that's what that means. We usually most of the time stick with the center. Alright. Then when you're doing outside or inside, guys, if you want to leave extra material, you want to additional offset, you can move another tool, another 25,000 also if you want to. That's your additional offset. So we're not gonna do that. I'm gonna make it 0 and stay to the center in this case. Yes, stock size, I can leave, stock to leave, I can leave 30,000. 30,000 doesn't matter, 30,000 is a good number to leave. Alright, rough radial parameters, here we go. Okay, maximum angle 2 degrees, I'll explain you how that works. Let's get with a bigger number. I'm gonna go angle increment of, let's say, 15 degree. We'll come back and change it. Offset distance, I'm gonna go with 100,000, maybe let's say 0.5. I'm gonna go little extra number, large number, so I'll show you how this works. Your start angle is 0, sweep angle is 360. That means it's gonna start at 0, it's gonna go all around the part and sweep to 360 degrees. Gonna cut it. Okay, start to leave. We are fine with that. Allow cut from both sides. We can do that, or we can just cut from one side. Allow multiple plunge along cut. Cut from both sides. This is gonna come in. It's gonna cut and go out. It's gonna also cut. Cutting method. One way. That's what we're gonna do. Or cutting method, we can go with a zigzag. Cut with one way cutting method, it's gonna cut in one direction. Maximum step down, that's your depth, how deep it's gonna cut. We can go 50,000, or you can jump, we'll definitely come back and change that to 100,000. So that's your step down. And angle increment, I'm gonna come back and change that. And we're gonna cut from both sides. Allow positive Z motion along the surface, so that means Z motion positive along the surface is gonna, when it's gonna start cut, it's gonna cut into positive directions. Along the surface, it's gonna cut it, that's what it said, allow positive Z motion along the surface. And cut depth. This is gonna be incremental, 100,000 each time it's gonna cut. We can go absolute also. In absolute, you gotta say the minimum depth, which is gonna be 0. The maximum depth, if you don't know the maximum depth, you should just right click here, say Z. And that Z, if you want to cut, we have to select the Z point, so I have to go back to my level, and I have to turn this wireframe on, and I'm gonna select, this is my Z right there. And then it's gonna cut from Z0 to Z minus 1, this depth. But let's say you want to cut up to this rectangle only, so you right click here and say Z, and it's gonna select that Z, you're gonna select that Z up to here, and that Z is gonna be minus half an inch, so it's gonna cut only up to half an inch. If you want to control your depth in absolute. But here, I will not, I don't want that, I just want to do the whole part. So I'll just go to incremental, and this must be, but actually it's not gonna affect, but I'll just go back to 1 inch here. I'll try to do it incremental. Alright. Adjustment to top cut 10,000, guys, this has, it's not gonna affect your cut, and it's gonna just, it says adjustment to top cut 10,000, adjustment to other cut 10,000. This adjustment is gonna be the cut when it's gonna cut from one surface to the another going down. that's what it is, but it will not affect anything, so you don't need to worry about that. And I'm gonna hit okay, and everything looks good. So let's hit okay, and let's see how that works, and then we'll go from there. How is retracting too much over here? Okay, so, the toolbar. So if I'm gonna run that. Each time looks like it's retracting, that is not good. Clearance to 2 inches, use only at the start. I will turn that off. Retract 250, incremental, sleep twin, I can do an incremental also. Let's do it again, there we go, that's better. Okay, alright. Let's go and see under verification, verify this. So first thing I want to do that I have a 50,000 front plane, yeah. I have my Z over here, so I have 50,000 stock on my Z, which is good right there. Isometric, and let's cut it. Okay. Okay, I'm gonna go and verify this and turn the tool holder off so I can see the tool. Okay, look at that tool, it's coming, and this is your angle right here, and this is the spot where it's reaching. It's not reaching to the center. If you look at the tool, guys, and look at that, it's not very cutting to the center. And if you look at this, the step over, and that controls your angle. So this is your offset from the center. So if you go to parameters, under radial parameters, that is your offset distance, 300,000 from here. So your tool radius is 250, and it's staying another 50,000 away from that. That's what it is. Your tool, you see that it doesn't go to the center, it stops away from the center. That is your offset distance. So our offset distance, my radius of the tool is 250, and I'll leave another 50,000, so I can put here 200 or maybe even 150,000. But now my tool is gonna move close to the center. Watch here. Look at that. It goes over the center. I put 150, we can still live with the 200,000, it still works. That's good, right there. And now this angle, the first and the next rough pass and the third rough pass are consecutive. This is the angle that controls that. That angle, just want to show you guys, I did that on purpose, 15 degrees. So the first was 0 degree, the second pass was 15 degrees. So subsequent passes was 15 degree angle. So I'll stay about 8 to 10 degree, that works fine. Let's go to 8 degrees and see how that looks. And that's better, so it's overlapping. This stock on this is, we are using a polymer, that's not a big deal on this one. But if you have as hard metal, you're doing some steel, then that angle has to be like 4 to 5 degree angles, so you don't have too much tool pressure if you're cutting some hard metal. So if I'm gonna go ahead. So let's go and verify this. Here on the wireframe, if you can turn this wireframe, you can see your wireframe, you don't have to, you can see your initial stock turned off. And just go and play it. And it's gonna go 100, we put 50,000 each pass, we're gonna go to 100,000. Change that step down to 100,000. There we go. So we can go ahead and, because we're gonna machine this part, the step down, we can go 100,000. And bring it to parameters. My speed rate is 60, I'll go 75 on that. Spinning speed is okay, plug rate is good, reflect is good. And we change that to start doing 100,000, 3 inches, 2 inches. Has to be not that much. Yeah, I don't need that, we can just go and stop at 250, that's good. So that is 100,000 step down. And there we are. Okay, so on the back part. On the back plot information, so that operation is going to take 7 minutes. And this 7 minutes is going to be very, very close when you're going to work on the machine, you're going to see it, it's going to be very close numbers, time. Let's stop that. Okay, so now, after we have seen our simulation that my part is gonna look like something like this. After operation number 1. So, what we can do, let me see. So, I can go ahead and create a stock model. I can go say stock model, create a stock model. So that stock model, let's see, that is gonna be a model. We missed one step, but which is okay. We're gonna go stock model, create a stock model, and that is okay. And that file is gonna be your source operation is gonna be surface radio. And we pick the source operation, which is this, set okay. Initial start shift is not defined clearly, I was saying definition parameter page. Okay. Rectangular is gonna be your all surfaces. Okay, is that. There you go. So what is stock model? You don't have to do it, it tells you that after I done my first two part rough surface, so this is how my part turn around. And you can always turn this on and off, but the way you create that, you're gonna create that your stock model. But under parameters, if you look at here, you gotta create stock model. I create a stock route from our rectangle, which was my stock size, and that was my stock size. If you guys remember, 3x4, 3x4/1. And then you're gonna create a surface rough. I named it the stock model right here, surface rough. So I'm gonna create that, and source operation is gonna be the last toolpath. That's your source operation. So it's gonna figure out from that source operation from the rough radial toolpath that how your part is gonna turn out, and that's how your part is gonna look like this. That's your stock model from the first part, or first toolpath. And you can always turn this off. This has to nothing do with your toolpath, guys. This has to nothing do with toolpath. You can always go ahead and delete that. It's just for your information. You want to go and check once in a while, okay, I've done the first surface of radio. So this exactly is what you did here. That's what it is. This is what we done here. And the simulation, you have seen it. Oh yeah, that looks good. This is how my tool has been, my first operation has been done. That's perfect. But once you close this, you don't see it. So you create a stock model, and that stock model is right here. And you check that box and see that display. You will see that, how that part looks after first toolpath. That's all about it. When we're gonna post the file, this has no function to create your program. Okay, so that is gonna be your first toolpath, which is gonna be rough radial, and I definitely want you guys to create a stock model for that. So I'll give you about 15-20 minutes to work on this toolpath, guys. Then we're gonna come back and we're gonna talk about our next toolpath, which is gonna be our, we can use parallel or we can use constant scallop. Constant scallop is gonna be a good toolpath for this. So it's gonna cut equal amount when it's gonna start from the bottom, from the top and the bottom down. That's gonna be our next tool part, we're gonna talk about, finished scallop. So why don't you go ahead and try this tool part, guys, and then we'll come back and we'll talk about the scallop and leftover. So we have two more tool parts to finish. So the next tool part we're gonna finish, we're gonna use scallop and we're gonna use ball and mill to finish that part.